Hello guys and girls, and welcome back. Today I'm going to be explaining to you guys linked lists, and this presentation was made by Lucian Silcox. I do not own anything of this presentation. I just want to explain it, just so some students have visual ideas on how this works. Lucian Silcox is an amazing developer and professor as well. You guys can look him up, and yeah. He was one of my professors as well. So let's get started into this. So, what is a linked list? Well, a linked list contains of multiple nodes, and these nodes contain any type of data value that you want, and it contains a self-referencing pointer. So basically, it's a node pointer that points to other nodes, or it's a node pointer that points to a null pointer. So similar as I'm having right here, let me get my pen. So right here, it can either point to a null or another node. Whenever you're creating this linked list, you're always going to have a head. In some cases, some professors also mention about tails. Overall, you can use both of them. A tail, I believe, would be... I don't know if it's a double linked list where you can move forwards and backwards whenever you want, but I'm going to be explaining that soon. So, yeah. This part, it contains the data, and this part contains the node. The pointer, I mean. So this part contains the pointer that connects to another node. Now, you might be asking yourself, why do we need this? Don't we have arrays that keep track of this information? Don't we have vectors that keep track of this information? Well, we do. Vectors are, dynamic arrays that allow to relocate memory and expand it. While normal arrays are kind of, difficult to resize. Have you guys ever resized an array? You'll have to do new integer size 5. That's how you resize an array. In some cases, I'm not gonna bring that up. You guys need to understand how to do that. But linked lists are kind of easy to implement. They're quite effective when removing or adding elements. Similar to a vector. You can add elements, you can push back. Linked lists do that. You can remove an element, pop back, vector, in similar cases. Now, when it comes to adding a linked list, doing execution, depending on where you're at, like beginning, end, or middle. In this case, we have this example that does it in the middle. What would you guys do? What would you guys do in this case? Would you just assign the new pointer to null? You can. They'll be at the very end. So what I mean by that is, assign this pointer to this node and make this pointer into null. That's what I mean. That's one example, and to insert at the very end. If you want at the beginning, you would, let's see here. Let's see. I could connect this thing to this one and connect the head to the back of it. That's one way you could do it. But let's say we want to add it at the middle. So I would first keep safe this node, because this node contains information for this node and the null pointer. So let's say we add a temporary linked list that contains these nodes. So we can deattach this part. So let me show you guys that. Let's erase this. So I deattached the pointer and attached it to this new node I want to add. And this new node's pointer needs to be attached to the temporary node I set up so that I can continue on the linked list. Now, linked list implementations, we're going to be explaining how to build a node and a linked list. So let's start off. So, what do we need to build this node? Well, a node, as I mentioned during the start, needs to have, variables or data, such as strings, templated class. It can be a struct with different entries, and it needs to have a self-referential. It says right there, pointer. So that it can point at other nodes. In some cases, you will have constructors. You will have other types of functions, such as insert, remove function. But overall, you can probably just... well, I don't think you will use remove function or insert. I think you just, have this constructor, create this, and set up the next node. So implementing the node is quite simple. We have our int data and our node pointer next. So node pointer next point at the next node that we want to add or we want to see. If you don't have that, then we would automatically set it to null. So in this case, we have a constructor and we're adding data to it. Let's say this data is 10 and it's the first node I want to add to my linked list. Well, we would automatically set this as a null pointer. Now, in some cases there's going to be, functions that you can have like, hey, I want to add this node to this. You would have a node pointer and the next will just be that node pointer, I believe. Yeah. It's a little bit confusing. Just let's try to make this have sense. So constructor is mostly just there to build the information, and every single time we have this node, we should always have null value, or else you're going to be going out of bounds in some cases, or it never has something. I forgot what would happen if it doesn't have a null pointer. You guys can test that out. As I mentioned earlier about templated classes, in this case we have a templated node that has the class name T and data. This T data can be particularly basically anything. Strings, integers, booleans, an array. I don't know if you can do an array. Probably. You guys can try. We have this empty list. In this case, the list head is set to null. So we have this head. No data, no nothing. It's just set to null pointer. And if we want to add, let's say another node. Let's call this node something cool, like 12. 12 is a cool number. We would just reassign the pointer to point to this and update this guy's pointer by saying it's null. Yeah, that's how that's an empty list. So there's some operations that I'm just gonna go briefly on. You guys can read the PowerPoint presentations, and overall, please look up Lucian Silcock's name. He used to work with several professors, and it's one of the best lecturers I've ever seen. Now, let's say we want to add a new element. As you can see here, we have a list head that contains a null and it's iterating through a while loop. And then, this is already a function that's pre-made. I believe so. Let's see here. So sin is the data, and it's an integer value data. So that's why we have this. So this node is from the standard library. I don't know if he has it here. That is a new node that constructor we. So this is the node from standard library. So it's just an example. What we're doing is we're adding this new data with the previous, with our current linked list. So this function, I believe, would create a new node, and it will be pointing. So that let me draw it out for you guys because it's a little bit hard to explain. I'm just gonna do these two arrows, and let's say I iterate through this 3 times, so I'm in count 3, and this is the list head I'm currently at, or this is the head. It's a little bit. Oh, sorry, guys. This is my current head. Whenever I want to add a new node, I'll just reassign a node at the very beginning. So this is our new node. And I'm just assigning it to the list head. That's what the new node thing is doing. I don't know the actual parameters, so you guys can look this up. But overall, there's a basic example. I have this linked list, and each time I'm adding a new element or a new node at the very start, at the very head of it. Now, let's say we want to traverse through the linked list. A simple example is, iterating through using a while loop and checking that your current node isn't a null pointer. So as this is not a null pointer, so basically the sentence right here, it's quite simple overall. So let's go into the example. So I have this linked list called head, and it's quite empty, but overall I haven't added any data. So we use this while loop and the linked list name called traversal. Whenever it's empty, so null, we exit out of the while loop. But since it's not, and let's say I put some data in it, I believe it's derived from the list is derived from the previous PowerPoint slides. But the important thing when it comes to iterating or traversing through the nodes is this part. So basically what this means, traverse equal traverse next, means that I'm going to the next data. So let's say I have this. So I'm currently in traversed, so I'm just going to call this T. And I want to go to T next. So well, how would I say this? This is technically T next. And whenever we do this, when we make T equal to T next, this node does not exist anymore. And this one is gonna be our head. I hope that makes sense. Overall, it's quite simple concept. Just remember that traversing equals traversing.next to iterate through the linked list. Now, there's a bunch of code, so you can read it. Adding a new item at the very end, so it's quite easy. Let's see here. I believe this one iterates to the very end. So, as it mentions here, inserting points and then the linked list head. If we don't have anything, we just create a new node. But we're iterating until we hit the very end of null pointer. So, let's say here I have this. I'm gonna stop making them look fancy. I have a drawing tablet as well. So, whoop, whoop, whoop. Whoop, whoop, whoop. And then here. We might need to charge it. So, what it means is that I'm traversing through my linked list, my insert, and I'm looking for this point. The null. If it is null, then I want to add data to it. So, I'm going to add this node. I'm going to insert this new node here. And I'm going to make, you see here, insert point at next equals new node, new data. Here we rely on the default node pointer in the constructor. So basically it's setting up the constructor. Okay, so basically what this one's checking is like, I'm not checking this node because this one's the first node. I'm checking the second one, checking if it's a null pointer. And then I'm continuing on until I hit null pointer on the while loop. From there, I would have this pointer equal to the null pointer. No. There we go. The next one, since it's null right now, the next pointer I'm gonna assign it to this pointer. Oh my god, it's a little bit confusing. So what I'm trying to say is that I'm just looking for what I'm looking for is next. I want next. The current node I'm at, the next pointer needs to be empty. There has to be no node. If there is no node, then I'll add a new node with data, which this new node I'm adding. So as you can see here in this piece of this piece of lines, this one's adding a new node and already setting it with a null pointer. And the new the insert point next is the previous node, and I'm just connecting it to this one because previously, if you can see here, next used to be a null pointer. If you don't have a null, then I think it crashes or something. So you're good. I'm gonna skip over these parts because I don't want to explain this for. It's kind of the same because I already explained it. Adding it to the middle. There's just the code on how to do it. Delete nodes, fairly simple. I believe you just use so we have a temporary head and a previous null pointer. If what did I say? If the temp is empty and there's data inside it, then we would delete it. If not, okay, this is a type of no deletion depending on where you're located. Overall, you're going to be iterating through it because let's say the first key I have, it is the key I want to delete. So you would delete it and then return. On the while loop, I'm iterating until I find the key. I believe, yeah. And data, yeah, until I find the key. If, let's say this condition is met and there's no key, then I return. So there's no data overall. And then because the key was not found, it was null. If it is found, then we delete it. By previous next, and then we delete that. Previous is basically this node. There's this previous, and there's a current node I'm working on. And this is the next node. What I'm basically saying here is I'm deleting this node by simply connecting this to here. And so this one does not exist anymore. And then you would delete it as well, so for the memory. Finally, delete the removed node to free up the allocated memory, so that's what we're going to be doing. So there's other types of linked list operations. Some are recursively. So let's do it. So, let's see. Sorry, my phone. A non-empty linked list is a head node followed by the remaining nodes. So, I don't know what that means. Wow. So we have this. Oh, okay, not empty. I was thinking that node was empty and it was followed by some nodes. Sorry. So basically, this linked list has something inside it, and it's a linked list is a head node followed by the remaining nodes. So it's and it can refer to us as tails. So I was mentioning there's something called tails. This means that many problems involving linked lists can be solved by processing the head of the list and then recursively processing the tail. How could I illustrate this? I think as we're going on to this PowerPoint, it might demonstrate that. Because you guys can look this up in some cases. I know someone's that's gonna insult me for doing this video, so not good to having that. Finding the length of a linked list is quite easy. It's doing it recursively, if you can't tell. So recursive function is a function that calls itself. And it's quite an easy implementation. So, similar to a while loop, what is the condition of the while loops you guys would input? Well, you would first check if, hey, is this head a null pointer or not? In this case, our base case, this is called the base. Base case meaning that this condition will be met somehow. In some cases, when you're doing proofs, you also have a base case. If this base case is not met, we would then continue on in just incrementing +1. And you might be asking yourself, why are we adding 1 to our linked list? Plus the recursive call. Well, the recursive call, once it hits the base case, will return 0. And after that, all the 1s are going to be accumulating. So let's say, how would I do this? So let's say I have this node, and this node has something. So the node's going to look like this. So from here is 1. From here is 1. And then I hit null. Oh, I have a null here. Also, there's our head. So the size of this is going to be 2. You might be asking, why not 3? Well, that's the head. So as it says here, head equals null. It returns 0. The head does not count as it doesn't contain any data. Displaying a linked list recursively. So there's one of the methods, you would call it, and similar process. You're going to be going next, and you can see out the data. Yeah. There's not much to it. You would just call next. If you're doing binary tree, meaning 2, this linked list would look like something like this. Let me see if I can use my pen. So here, I have these nodes. I'm explaining this without explaining what binary tree is. But binary tree has similar properties. But in this case, we have a left and right rather than next. So in this case, we will iterate through this as left, and we would display this. I don't know why I'm explaining this, dude. It's not part of linked list. It's binary. It's a different thing. Although you are using it in binary trees. So when you're iterating through it, we would always check, you would have a queue. But in this case, I don't know why I'm explaining this one. There we go. Let me do this. There you go. So this thing, let's add a head, because in some cases people add heads. The circle is our head. Oh my god, if I can do this. The circle is our head. And this thing has a property of 12. This thing has a property of 20. And this thing has a property of 3. It's increasing, I guess. It would first display 12, and then it'll do a recursive call going on to 20. So then it will display 20, and then it'll call the function display again on the next to display 30. And whenever it's a null pointer, because this head's null, it stops the recursive, and yeah. There's other recursive functions. We can also use recursive solutions for. You can, when it comes to recursive functions, it's basically adding a for loop. It's basically adding a while loop. In this case, you just need to have a condition of having a base case, and what are you doing after that base case? The else statement. And mostly you can do the same things like adding, removing, adding at the middle, mostly anything. So, as it says here, some general design considerations are the base case needs to have a head null pointer so that you can exit the function. And I have done a leak code on this one. It's pretty fun. I don't know how to. I forgot the name of it. I don't know the name of it. I didn't explain Tails, but there's just regular linked list. So, variants of linked list. There is this thing called, I mentioned double linked list. Basically, you're going back and forth, so let me explain that. A circularly linked list. This one's pretty interesting. Basically, there's never a null pointer. And I believe this is the leak code problem that I didn't know how to solve, because it's always iterating. So basically there's no null. In some cases we might we would have to check it's quite difficult to check how to end this linked list when you're not using a null. So in some cases you can probably have a statement like, hey, if the value here is 10, can you please cut off? Or if it's taking too long, you can cut off the function or the loop. In some cases, you can also do, let's say you want to loop through a linked list, a circular linked list, 10 times, and let's say you only have 4 elements. Well, you're going to be repeating those 4 elements, 2 times and 2 extra, to make it 8 elements overall. But overall, these are circularly linked lists. It's pretty interesting, I guess. You guys can play with this. Now, let's get into the one I was talking about, which is double linked list. So basically, as I mentioned before, how binary trees are made. You have a left and right. When it comes to a double linked list, you have a kind of the same thing, but it's called next and previous. So the head is here, and this link is called next. And as I'm progressing, the last node that I have will always have a null pointer, just to make sure. When it comes to next, this is the next null pointer. I have a left one as well, so the left one will contain this the previous node, which the previous node would also contain the previous one, until it tries to reach for the head, which is just a null pointer. It doesn't exist. So I hope you guys enjoy this small lecture. I know that I'm horrible at explaining, but I'm trying my best out here. And overall, I hope you guys enjoy this lecture and this PowerPoint. It was made by one of my dear professors, Lucian Silcox. Greatest mentor I ever had. I would always talk to him about several things, honestly. But overall, thank you for watching. I know the video was horrible. I know my explanations were not that nice. But the journey wasn't about me, but it was about admiring and trying to understand what's happening in this PowerPoint presentation. Other people can probably explain it better, but I just wanted to put this up there so anyone can see it in the future, because you never know. Not many people have seen this presentation. Not many people have knowledge in linked list. And I also did this video for one of my friends since they had difficulties or didn't really understand how linked list works. So yeah, hope you guys enjoy, and please look up Lucian Silcox if you ever have time. Very great professor. He works at he used to work at STC. So yeah, thank you guys, and take care.